Hey everyone, and welcome back to another video of me solving homework 1. So this is going to be the solution to part 3. I need to explain and code a function that calculates a surface point at a distance with a radius of 0.5 from the central helical curve for arbitrary angle theta between n and the cross product of t times n. Why is it necessary to use the cross product? So I think I really want to break this down into two parts. One is making the function, and then one is explaining why use the cross product of t times n. But I'm actually going to do this cross product of t times n first. So if I go to Frene-Serre, we see t times n will make the vector b. B is the binomial unit vector. And the really important thing is that the cross product of n and b make a plane. And that plane is really cool because the plane is always tangent to the curve, no matter where the curve loops or swirls or wherever. And the plane created here is always going to be perpendicular. And that's going to let me, say, generate a list of points. And then I can take those points and make sure they're always equal to a certain thing on the curve. And so let's just go ahead and maybe review real quick what I have so far. So up here, I'm just defining and doing a basic plot. This is the thing we're trying to build a wireframe around, which I demonstrated. I showed the final product a couple videos ago. And then I also generated this Frene-Serre function. And what the Frene-Serre function does is it kind of generates this dt and the dn, and then it just returns it just returns tangent and normal, these tangent normal values. So I'm going to go ahead and start off by copying this tangent normal down here, just to make sure that as I'm trying to plot the wireframe, it's still tangent and normal are still kind of the functions defined the way I had them defined in the last video. And so I'm going to define surface. So actually, I want to create a function of the surface points. So I'll just define that as surf. I'll just leave this surf. It's pretty descriptive. And I want to give it, I want to have it in terms of t, so at a specific value of t, or even at a list of values of t, and then at a certain value of theta, right? And then, so I'm wondering, what is theta? Well, theta is obviously like a radian value for angle. So I'm going to go ahead and define theta as a list. I'll say it's not np, jnp, lim space, starting at 0, and then going to jnp dot pi. Well, it actually needs to go to 2 pi because that's 1 full radian, right? And then I need to give a certain number of values. I can't really think of any reason to do anything specific, so I'll just say 16. But anyway, I'm trying to define this function. So return, and then I need to return some surface points. But let me work my way there. So first off, let's go ahead and say that t is equal to this tangent function. And if I could spell it, tangent. Tangent function at some value of t. It's not relative to theta, it's just relative to t. And then n is just going to be the same thing, but for the normal, relative to some value of t. And then, did I spell tangent correctly? T-A-N-G-N-T? Okay, yeah, that's good. And then b is going to be the cross product of the two. So if I go ahead, I think I have this, yeah, Jack's numpy cross product. So I just give it a value of a value of b, and there's some other information, but that doesn't really matter for me right now. So cross, the cross product, I'll get it eventually, at a certain value of t, at a certain value of b, or not b, at a certain value of n, right? And then also I'll go ahead and come over here and maybe give it a value for the radius right now. So once again, I talked about cross-sectional radius of 0.5. So I'm really trying to use this radius as like, I'm going to go around the point 16 times for a full rotation. That's what this is saying, at a radius of 0.5 points. And I have all this together, and I need to return something, right? But what should I return? That's a good question. I'm going to go ahead and head over here into Paint to try to explain it. So that's what I'm doing, but let me just delete it all. I think I can hit delete, right? Okay, sweet. I'm getting used to a new keyboard. And let's just start from the beginning. So let's say I am in like a flat two-dimensional curve, right? So maybe it looks something like this. And I have a circle that looks like this. Well, if I wanted to get maybe say the x and the y values of like the perimeter of that circle, I could draw a line, right? I could draw a line like this, and I could say it has some value of theta, some angle, and there's some radius, which I know, and then x and y would just be equal to the radius times the cosine of that angle, and then y would just be the radius times the sine of that angle. So that's pretty sweet, right? Now let's say we go back to my three-dimensional curve, and now I have some spiral, right? Well, I could take this two-dimensional circle, right? And I could put it on the spiral at any given point, but it would be kind of weird unless I had some plane that's always perpendicular. And so that is what the cross product of these two, or specifically the, shoot, what am I looking for? Specifically what the matrix multiplication, or I guess like n and b, n is like the x-axis of this flat plane, and b is like the, or I guess b is like the x-axis of this plane, and n is like the y-axis. So I can go ahead and I could take a, whatchamacallit, what is the word? I could take basically an array of n and b values, and I can multiply them, do a matrix multiplication. So I guess it's a matrices, not an array. But I could do a matrix multiplication of these, so the x values and the y values adjusted for theta, and then that would give me a list of points. So I'll just say points. I don't want to write it all out because I'm just using a mouse to do all this. And so that's sort of what I am trying to do in this problem. So I'll go ahead and get rid of that and maybe bring up this. Ooh, we got a nice view of Frene Serre. Good guy, good guy. And I'm going to do exactly what I talked about in the paint file, right? So I need to somehow get all of these n and b values together. What I'm going to do is use something called stack. So jax.numpy.stack, we give it a list of arrays, we tell it what axis we want it to be on, and it will kind of merge and zip the two arrays together. And I don't think zip is exactly the right term, but I think it's kind of, it's sort of descriptive. It'll just put them all together on a certain axis. So I will go ahead and return, what is this called again? Stack. So numpy stack function, and I will give it a list of arrays. So n and b are the list of arrays, and then the axis is going to equal 1 because I want it to be in the y-axis, and the y-axis is 1. And then I want to matrix multiply that, remember, from here, matrix multiplication with x and y. So I will just define this as an array. So np.array should be jnp.array of, I made so many mistakes like that when I was practicing this, but times cosine of theta. Yeah, that's correct. And then I'll go ahead and get to the next one, and the y value is not there. There. It would be sine of theta. So sweet. I have all of this generated, and let me go ahead and run this and see if I get any weird math errors. I don't. So now if I were to go ahead and start another code cell, I will say maybe surf at a certain point. This is actually not going to come out to correct, but I'm going to do it anyway and explain why. Let's just say when the time is 0, and when the theta, so the angle we're looking for the point is 0. Let's see what I get. I will get a number, but it won't really be sensible, right? Because I'm looking for a value on the curve at these coordinates, right? So it's telling me I should put a dot on the curve at these coordinates, negative 0.5, 0, and 0. If I go back up here, negative 0.5 on the x, 0 on the y and z is like somewhere in here, so this obviously isn't like around this plane. And you see, what I have right now is not the actual point that I'm trying to get to. So it's not the actual point I need to plot, but it's the point I need to plot relative to the curve, right? So what I need to do is I need to take curve, and I need to take curve at a certain value of t, and then just add that on there, right? So if I go ahead and run that, and then I run the surface function again, I will get an array that makes a lot more sense. So it's still 0 and 0 on the y and z axis, but on the x-axis it wants me to plot at 2.5, which would be like, this is not helpful. That view is not very helpful. Whoa, I'm ruining everything. Wow, that's cool. Okay, I didn't know you could do that. I'm holding down my middle mouse button to make that happen. Okay. I don't know how I exactly made that happen. But that would be like a point right here, right, where my cursor is. And so that is like a 0.5 radius from this plot, and that's I guess what I'm looking for. See, the problem is, right now, surf is just giving me one value. So that's kind of a problem, right? That's not really what I'm looking for. I'm looking for surf to give me a big list of values that represents where the curve is. And so what I'm going to do is I'm going to use numpy, or Jack's numpy's vectorize function. And what it does is it gives me a function to vectorize. It gives me a signature, or I give it a function to vectorize, and I give it a signature, and it's going to return a vectorized function. And the excluded is just sort of an optional thing. A signature may also be optional. I'll try to run it without signature. But what I'm getting at here, what even is vectorizing, like in general? Well, vectorizing is where you take a bunch of functions, or not necessarily a bunch of functions, but a bunch of stuff, a bunch of matrices, and you sort of put them all together in one big matrices, creating new dimensions if necessary, and doing that sort of thing. So I'm going to go back here, and I'm going to say that maybe surf vector is going to be equal to surf's function. Surf, I can't type. Well, no, okay, so I need to go jnp dot vectorize, and then I need to vectorize the function surf, right? So I vectorize the function surf, and what else do I need to give it? Maybe nothing else. I'm not certain, but it probably won't like that. I don't know. I haven't practiced it without giving it, because usually you have to give it the signature, but I don't know if it will automatically figure out the signature. So I know what I need to give for a signature, but let's try to do it without the signature. So if I do surf the vector, it wants now a value of t and a value of theta. So I will just give it maybe 0 point and 0 point. So that's saying when t equals 0 and when theta equals 0, what is the vectorized version of surf? So what is sort of all the points together? And theoretically, because I'm not giving it any lists, it should just be 0. It should be the same thing as this device array. So let me see what it gives me. Ooh, it doesn't like it because it doesn't like the shape. So that's kind of what I was anticipating, the type of error I was anticipating getting. I need to give it a signature. And what the signature is basically saying is when I give you vector of a certain magnitude and length, or a vector of certain dimensions, and then another vector of certain dimensions, I want this vector returned. And so what I'm actually going to give it is a scalar. I want to give it t is a scalar, and then theta is a scalar, and I want to turn that it's going to turn that into a vector with 3 values. So that would be the x, y, and z coordinates. And so I'll go ahead and run this, and now it gives me the same thing as I did before. So if I were to run t and then theta, so 2 lists of values, or I guess arrays of values, it's going to give me an error because the shapes are not compatible. How unfortunate. Well, what I'm going to do to counter that is I'm going to go from 0 to the end of the array for t. So I'm going to say, as I go through t, I'm going to take these certain values, and then for theta, I'm going to do something similar, but the inverse. So I'm going to take these certain values of theta and multiply them together. And now when I create a surface vector with those parameters, it still messes up. That's unfortunate. I feel like I'm missing something. Try running it again. Didn't work. Okay. Shoot. Taking the right vector. Let me pause for a second and figure out what I have wrong here, and I'll get back with you once I figure it out. Yeah, so I'm back, and I had like a 0, whatever. I shouldn't have let that 0 in. Instead, I should have separated it with a comma. So now that I have this comma separated, it should give me what I'm looking for, right? So let me look at the shape of this array, because I think that might be the best way to explain it. Yeah. So, yeah, sweet. So this is exactly what I'm looking for. I want to go from, I'm saying at 100. So, yeah, okay, let me restart this. We have this surface vector at a certain value of t for a certain duration, and then string that together with the certain values of theta over certain a certain list of points. And I'm going to get 100, 100 points. So that's saying 100. It's saying, it looks and it says, okay, there's 100 values of t from this n value, right? So there's 100 values of t. And then for every value of t, I've generated 16 new points around that value of t to make up the circle. That comes from theta, right? So theta is 16, has 16 values. And then for each of those 16 values, I have three values or coordinates, x, y, and z coordinates. So this is what I'm looking for. This is what I wanted to develop, right? Is vectorize the function and generate a plot of the surface. Actually, no. Okay. I explained a code of function that calculates the surface point at a distance d from the central helical curve at an arbitrary angle theta. So I actually went a little bit further and did part of part 4. So I guess I already vectorized the function, and now I need to just generate this plot. So I'll circle back around with you to generate the plot once I'm ready to do that. But thank you very much for watching, and I appreciate you watching. I hope you learned something. I certainly did. And have a nice day.